In this video, we're going to take a look at parabolas. Now, the way that you get a parabola from a double napped cone is you take a plane and you slice it, and the plane is parallel to the angle of the cone. You get a curved shape, and we've looked at parabolas before as functions, but now we're going to look at them as conic sections. The way we've looked at parabolas before was as a quadratic function, and it usually took on this form. We knew that if this a was positive, it opened up. If it was negative, it opened down. This number a also helped determine whether the parabola was taller and narrower, in other words, there was a vertical stretch, or if it was flatter, which would be a vertical shrink. The larger that the absolute value of that number is, the narrower the parabola is. So here's a new definition, and it's based on a group of points. So if we have a group of points xy that are the same distance from a fixed line and a fixed point that's not on the line, we get a parabola. So let's look at the parts of a parabola in this context. So we first look at our parabola here. This is familiar, we've seen this before, but now we're going to look at a directrix and a focus. And what is true about all parabolas is that the distance here is equal to the distance here for any point. So let me take another point, and if I measured the distance here, and for this one I'm going to call it, I'll just call it B. That would mean that this distance here is also B. It has to be the same distance. So we're going to look at parabolas a little bit differently today. You also are familiar with the fact that we have an axis of symmetry for all parabolas because parabolas are symmetric. So now let's look at the standard equation. Different textbooks will list the standard equation differently, but they all have the same idea in mind, that we have to find that key distance between the focus and the vertex and the directrix to help us find the equations of the directrix and the coordinates of the focus. So for our textbook, we are using this for our standard form. This is familiar. This is exactly the vertex form that we looked at in the fall. This is the form that it takes on if it is not a function, but it opens to the right or to the left. This is a function, so we studied this form when we did functions in the fall. This one is not a function. If you have y equals x squared, you're going to get a parabola that opens up or down. If you have x equals y squared, you're going to have a parabola that opens right or left. So that's what you want to look for. Find out which of the variables is being squared. Now in both cases, we have this relationship between the number that's out in front and the fraction 1 over 4p. P is an important distance. It's going to tell me how far the vertex is from both the focus and the directrix. So we're going to look at this a little bit closer in our first example. Now if your parabola has its vertex at the origin, then you get this simplified version. We still have our number a, and our number a is going to come into play as we find our focus and our directrix, but we also know that the number a comes into play when I look at my standard pattern of change. So let's look at an example. We're going to graph the equation y equals 1 over 16 times the quantity x minus 3 quantity squared minus 5. So the first thing we're going to do is figure out what the vertex is of this parabola. And if you remember from when we did this before, when you find the vertex of a parabola, you need to look at the number that's in here with the x, and we're going to use the opposite of this number, If I see a minus 3, I'm going to use a 3, and then we're going to use exactly this number. So my vertex is going to be the point 3 comma negative 5. So when I go to 3 negative 5, I'm going to put my vertex right there. The next thing I'm going to do, and I'll label this as V for vertex. The next thing I need to do is I need to figure out what that value of P is so that I can determine how far to put my focus and my directrix. But before I even do that, let's notice that since this is a y equals x squared, my parabola is either going to open up or down. Now on my y-axis, these are the positive y values, and down at the bottom we have the negative y values. If this number is positive, it's going to open to the positive part of my y-axis. If this is negative, it would open to the negative values on my y-axis. But what I have here is a positive 1 over 16, so I know that my parabola is going to open towards the positive y's, which means it's going to open up. All right, now I also know because of this fraction that my parabola is going to be flatter than the normal shape. The normal pattern of change is 1, 3, 5, which means from the vertex I go over 1 up 1, over 1 up 3, over 1 up 5. If I have a number in front of my squared quantity, I need to multiply that. So our new pattern of change would be 1 over 16, 3 over 16, 5 over 16. So that's a pretty flat parabola. I'll put a couple points on. If I start at my vertex and go over 1 and go up 1/16, and then go over 1 and go up 3/16, then go over 1 and go up 5/16, that is not a very steep parabola. And then, I know that I've got my axis of symmetry, which acts like a mirror line. So here's my axis of symmetry. So I can take those points and mirror them straight across and get a pretty good idea of what my parabola is going to look like. It's pretty flat. It's going to look like this. Okay, now the next thing I want to do is I want to find where my focus is and where my directrix is. So to find the focus and the directrix, I'm going to need to know what that P value is. So my formula is the absolute value of A has to equal 1 over 4P. Since my value of A is 1 over 16, that's what's going to go in there. So that means I have the absolute value of 1 over 16 equals 1 over 4P. Well, the absolute value of 1 over 16 is just 1 over 16. I get 1 over 4P, and for this one, I can just look at it and I can tell that this number here has got to be 4 in order for that to be true. So I have P equals 4. Okay, that means from my vertex, I'm going to go up 4 units, and I'm going to go down 4 units. Inside the parabola will be my focus. Outside the parabola will be my directrix. So this is a line, not just a point. The equation of this line, it's a horizontal line, so it's going to be y equals a number, and if I count down my units, I get y equals -9. If I count up to my focus, I can see that my focus is the point 3 comma -1. Here's another parabola. This one starts with x, so I've got x equals y squared, and we know from before that when that happens, I know that my parabola is either opening to the left or it's opening to the right. And which one of that is the case will depend on the sign here. If this is a minus, in which it is, then my graph is going to open towards the negative end of the x-axis instead of the positive end. So for my particular graph, I can erase this one because I know that my parabola is going to open to the left. Now I'm going to actually write down what my vertex would be. Now here's where you have to be super careful because of what we're used to doing from when we studied parabolas before. Do not tell me that the vertex is 2, 4, because the y here tells me that this is going to give me the y coordinate of the vertex, not the x coordinate. So my vertex has a y coordinate of 2, because that's what I see here in the parentheses with the 2, and I need the opposite number. And then this is going to be not changed. It's going to be a positive 4, but it is the x coordinate. So the vertex of this parabola is the point 4, 2. So there's my vertex. The next thing I'm going to do, I've already decided that it opens to the left. I can look at my pattern of change. Let's do that. The pattern of change is normally 1, 3, 5. So we have learned to multiply that number, in this case with negative 1/2. Our new pattern of change is going to be negative 1/2, negative 3/2, negative 5/2. That negative just means we're going in the negative direction. So in terms of my parabola, I would go up 1 and to the left 1/2, right there. Then I would go up 1 and to the left 3/2. Then I would go up 1 and to the left 5/2, which would leave me right there. So let me erase those little dots that I put there. I have my axis of symmetry, which is going to go right through here, which means I can mirror my points across to this one, and this one. So my parabola is going to look like this. And now I'm going to look for the focus and the directrix. So I'm going to do the same thing I did before. My equation is the absolute value of A equals 1 over 4p. My value of A is negative 1/2. And when I clean that off, I get a positive 1/2 must equal 1 over 4p. Easiest way to solve this is by using cross products. I get 4p equals 2, divide by 4, and p equals 1/2. What that means is that I'm going to go 1/2 units into the center, the inside of my parabola. That point right there is going to be my focus. Then I'm going to go 1/2 of a unit outside of my parabola, and that's going to be my directrix. So I'll make a dotted line here to represent my directrix, and that is going to be the line x equals 4.5, because if it's a vertical line, it's x equals a number, and it carries the value of 4.5. My focus would be the point 3.5, 2. Okay, for this one, we're not asked to graph it, we're just asked for the standard form of the equation. But in order to get an idea of which basic equation I'm looking at, we do need to sketch just at least part of the information. I'm told that the vertex is at 4, -1. So I will put that on there and then label it with a V. and it says the directrix is the line y equals 2. Well, if the directrix is the line y equals 2, that's a horizontal line right here. So given those two pieces of information, because a parabola will never cross its directrix, I know that my parabola is opening downward. And if that's the case, then I know that the equation that I'm looking for is going to be y equals a x minus h quantity squared plus k. Now I already know the vertex, so I know it's y equals a x minus 4 quantity squared minus 1. So the key here is for me to find the value of a. Now if I know the vertex, then I can count from the vertex to the directrix. This is 3 units. And the distance from the vertex to the directrix is what we call p. So I know that p equals 3. If I needed to find the focus, I could just go 3 units down, and that would be the focus. Now I'm not asked for that in this problem, I'm just asked for the standard form of the equation. So I need to go back to that same equation that I've had before. Absolute value of a equals 1 over 4p. So the absolute value of a equals 1 over 4 times 3, since p is 3. So now I've got the absolute value of a equals 1/12. So the question is, do I want positive 1/12 or negative 1/12? Because when I solve this, I get x equals 1/12, or, that's not x, but a equals negative 1/12. Well, your answer is going to be based on whether this parabola opens towards the negatives, which it does, or if it opened toward the positives, which it doesn't. If it opens towards the negatives, then we need to have a equals negative 1/2, and that's what we would put up in here to finish our equation. So I'm just going to erase that and put in negative 1/12, and this would be our equation. All right, for this problem we're going to find the standard form of the equation again, but this time we're given the vertex and a focus. Well, we still need to figure out what our basic equation is going to look like, so let's sketch what those points are going to look like. I've got the point 1, 5, and that would be right about here, and that is the vertex. The point negative 1, 5, right here, is my focus. Okay, right away, I already know that my parabola is going to open to the left because the focus is always inside the parabola. Another thing I know here is if I look at this distance here, I can tell that p is 2 units. So if I needed the directrix, I would go 2 units outside my parabola to get the directrix. In this case, I don't need the equation of the directrix, so I'm just going to take the knowledge that p is 2 and let that help me find my equation. Now, because it's opening left or right, in this case left, my equation, my standard equation, is going to be x equals a, and then y minus k quantity squared plus h. All right, I know that my vertex is negative 1, or is positive 1, 5. So when I put that in there, I'm going to get x equals a. I'm going to take y minus the y coordinate, which is 5, and then plus my h, which is just a positive 1. Okay, so now it looks like I just need to find out what a is again. So my equation is the same as it was for the other problems. The absolute value of a is 1 over 4p. In this case, I found that p was 2, So I've got the absolute value of a equals 1 over 4 times 2. So I get the absolute value of a equals 1/8. That means a has to equal 1/8 or a has to equal negative 1/8. So which is it? Well, if you look at this parabola, it's opening towards the negatives. So I'm going to need to use the negative value for a, not the positive, because it's opening towards the negative end of my graph. So my final equation, if I go back up here and stick in negative 1/8, I'm going to erase that and I'm going to put in negative 1/8. Let's do it in black. Negative 1/8. This is the equation of my parabola.